Are we recording? There we go. Take one, sorry, take two. The Heights, formerly known as Hillcrest Sustainability Workgroup meeting number 4. Welcome everyone who is not here in person on this call. The agenda for today, we're gonna start off with next generation stormwater. Bob is going to talk about, and Bill are going to talk about some site-specific strategies that have already been put forward, and some that are yet to be further developed for the Heights. I'm going to run through a few precedent examples of some of the cool stuff we've done historically in this area to see if any of that resonates with you folks. Some of it is stuff we have not talked about doing yet at the Heights, but I think there might be some reasons to do it. And I might freak Bob or Bill out because I don't think I've ran any of it past them either. So we'll see here.
We'll adapt on the fly.
Okay. Then we're going to talk about embodied carbon. Becky, and I don't see John Metza on the call, but I know we had asked him to talk a little bit about his drive and desire to build a net zero mass timber building for his business on the site. And so hopefully he's going to join us for that. People wanted to talk about workforce, and so we've got a few slides and some sort of a preview of something that is just going out to be vetted on our new workforce agreements. And then we'll talk about next steps as we wrap up here. So with that said, I'm going to start sharing this deck, if it's on the right screen. Yes. I'm sorry, did we not have Becky and Tiffany give us their Earth Day insights and mementos? I don't think we did, guys. So let's, you thought you were going to get away, didn't you?
Oh, you noticed.
Yeah.
Okay, I'll go next. On Earth Day, every day, really, it's really easy to get super fired up when you think about how many things go wrong, have gone wrong, might go wrong. But it helps to think about how many things have been fixed. And so I used to teach undergraduate geology, and they were a never-ending font of inspiration and hope. And they would bring me all of these terrifying reports about the Great Pacific Garbage Patch, which was one of the things that I had first heard about it when I was a very young professor. And one of my 18-year-old students brought it to my attention. Friggin' horrifying. But then the next person did a report on the ozone layer and how it's like, we changed our policies and we fixed it. Like there was a recognizable, measurable success based on policy changes. The Ohio River used to be on fire and it's not anymore. And you can almost like stick your feet in it now. It's that clean. So progress is being made, and it's really encouraging to participate in a group of people who take it so seriously and just to recognize the power of policy changes.
Thank you for that perspective, Tiffany. Becky?
Yeah, I'm in a similar boat to many of you, where I'm seeing today and thinking today about a lot of things that we've lost over the years. The Google, if you've done any Googling today, you're seeing comparisons from 5 years ago or 10 years ago or 20 years ago to where we are now in some of these natural resources, and it's pretty depressing. So I keep looking over to our team's vision at LHB is really inspirational about designing regenerative communities, and remembering that I work every day towards that is what I'm thinking about today.
Well, you are a rock star, and I really appreciate your assistance on this journey we've been on here, Becky. So now, are you guys seeing this slide deck, the Heights Sustainability Workgroup, right? Mm-hmm. Okay. Agenda. We walked through Lead for Communities in meetings 2 and 3. We asked you at the end of last meeting, what is beyond LEAD that you wanted to talk about? And the answers were next gen stormwater, embodied carbon, and workforce strategies. So I'm gonna let Bob start and go through the site specific stuff for the Heights, and then I'll show you some stuff we've done historically that might be in play here. Bob, do you wanna I can flip through these slides for you. I think these are, this was the information you sent over, I think reformatted into this deck here though. So
Okay.
if it looks different, I think it's still your work.
Still
Yeah,
my
this
work.
first one is actually just from the master plan.
Okay, this is the master plan, which, I mean, the language in the master plan, is the second slide then more on the district concept, Becky?
Yeah,
Okay.
yeah.
I won't get too much into that here then. So master plan language, we talk about this a lot, treat stormwater as a resource, maximize its benefits, but really in reality, what this means is we use it as a visual element as well as a practical regulatory treatment type element. And, you know, Bill and I actually just had a meeting on some of the design concepts we're trying to implement, and we do think about that, right? Because one of the aspects of this is that it's very practical, though expensive to use underground storage, particularly in a heavily graded site like this. And yet we do want to tend to pull back from that, and we want to put some of the stormwater matches, actually as much as we can, on the surface. We have obtained various values from that, both biologic and a higher level of treatment, so to speak. So that's really what the master plan was getting at when they're talking about light touch. What are the aesthetic components of stormwater? There are aesthetic components even in hardscape. So, you know, a lot of people react well to hardscape elements that come into the stormwater system. So if we're doing a rain garden, we have some stonework within that, or a carved weir. Things like that, I think people really react to nicely. They are expensive, but it's incumbent on us to integrate that into the landscape. Economies of scale, I think those really occur when we're using landscape and stormwater in the same aspect, right? That we have a certain amount of landscape that needs to be brought into the development and naturalized. To the extent we can marry that with stormwater, we've saved on land space. And do it in a way that both aspects of both values are brought forward, that we're not overwhelming a landscape, for instance, with stormwater, over flooding, killing vegetation, things like that. So we have to be thoughtful on that. And then yet to be done or yet to be totally quantified, really encouraging, mandating and encouraging. I think there's two aspects to this. One, in the mandate realm, we have to be very clear that building owners, we're going to want them to drain their buildings out onto the surface. You know, the typical, almost all our builders want to interior drain buildings, and we're going to, you know, want to maybe do that where it has to be done, but in a lot of ways encourage buildings to be drained onto the surface and then taking that water away from the building. And then to the extent they can't, maybe thinking about how we reuse that water for irrigation.
This is one where we've got two competing sustainability goals or strategies. One being maximizing rooftop solar and putting a really maximal amount of solar up there versus doing green roofs or other rooftop treatment type ideas. So
yeah,
we'll do it where we can do it, but I think in terms of pulling the biggest lever on climate, we need to get as much renewables on site on these rooftops as possible. So there's a little bit of tension there.
Yeah, and I think you know, green roofs are very, very expensive, and to the extent you can find space within your site, other areas of your site, you've saved yourself a money. You can capture the same sort of benefits.
Yeah. Bob, do you want to? Oh, I wasn't sure the map. I don't know that folks are familiar with the concept.
The schematic. So explain the schematic in a minute or less. It's like a game show. I'll try. So, I mean, this came out of the master plan. It was actually to conceptualize what more so the thematic elements within the system would be. So on Arlington and Howard Street, you'll see a linear feature, and that's really a BMP, right? It's a combined conveyance and treatment BMP. Now, what's interesting about that for us is that by combining conveyance and treatment, we really accomplish two things at the same time. But we do have to be a little bit careful about not overemphasizing conveyance and not accomplishing the treatment we want. So on Montana, Howard, and Arlington, you see those features. We also have a lot of underground storage. We have a realization that in creating industrial space, there's a certain amount of pavement and building that just needs to occur. And so within the master plan, there was a decision to also indicate the need for underground storage. And it, you know, they roughly proportion what that might be. Now, underground storage in some locations might have infiltration associated with it. In other locations, maybe not. And we're actually currently looking at where that makes the most sense. Generally speaking, toward the southwest part of the site, infiltration is more available to us. And then toward the northeast part of the site, the east and north, not so much. Now, some of you may say, well, there's contamination on the site. So we are going to have to work with the PCA, the watershed, and the city to understand their tolerance for, you know, after we remove the contaminated soils, are we free and clear to pursue infiltration where it makes sense? And we think that we will be, particularly since some of the infiltration areas don't have contaminated soils. So you see those gray areas are really a schematic of where underground storage would occur. And then, of course, we have wetlands on site. And wetlands, I usually view, I don't say they're not part of the treatment system. Regulatory agencies will say you have to treat upstream of a wetland, but a wetland can serve to polish water, I call it, just to kind of finish it up, to really add an extra level of resiliency to the system. So we do rely on the wetlands to provide those functions, and really we have to maintain hydrology of the wetlands. And then we have surface ponds as well as part of the system. What's not shown are what I would call the small scale BMPs that will be integrated into the site. And those could be tree boxes, rain gardens, rain gardens in parking lot islands, all of that would also be part of the system and integrated into it. The one concept here, though, as we look at this, what you see is that the public realm and the private realm are mixing their water, right? And that's not always done. And so that's where we come up with the concept of district stormwater. District stormwater for us is really the idea that what is the most practical way to move water and treat water without thinking too much about the boundary between the public and the private realm. What we're trying to do is be practical and holistic and not so much think, well, the municipal system is here, the private system is here, let's separate them. We're trying to be more efficient to get more treatment out of a certain amount of expenditure. And that lends itself to the district concept. And a district really means, I mean, it's a philosophy in some sense, but it's also a financial structure. In a district, we identify what those combined costs are going to be in the public and private realm, and we attribute them to the development. And then we make sure the stormwater utility, a special district might be created in the stormwater utility that funds those activities and the maintenance of them long term. And that's really the idea. So that's part of our job, is once we get buy-in from the city and others on the district concept, with nuances. Obviously, people are going to want to say, okay, well, let's separate here and we can combine here. But once we get that buy-in, then we will want to create that capital improvement plan and maintenance plan and then structure so that can get implemented for the development.
Bob, is it accurate? Is it not accurate to say this district approach, regional approach, and the sharing of public and private stormwater and the BMPs and the conveyance systems to deal with it is probably more common in the suburbs than it has been, at least in the city of St. Paul? I know we've had some fairly epic battles over my 17 years here. For separation of church and state, of the idea of public
separation of church and state. Yeah, it's actually even a little slightly difficult in some of the suburbs. So yeah, certainly it's been, I don't know if it's controversial. It's been a source of debate in both Minneapolis and St. Paul projects I've worked. And sometimes projects are small scale, so the debate doesn't even occur, right? If you have a small scale project, you're private, and that you have to achieve a certain level of treatment by the time you connect into the municipal system. Here, we're a little bit jumbling up those definitions a little bit, so it's a little bit unique that way. But it is this, I would say there are certain suburbs maybe that are completely integrated, private and public, and that there are certain suburbs that have a little bit of that distinction, but certainly Minneapolis and St. Paul have maintained a fairly strict definition of the boundary between the public and the private realm on stormwater.
And Russ's comment in the chat here is very appropriate. We were very involved in the cleanup at Allianz Field, and since we were in the dirt and dealing with pipes, we were also involved in the reuse system there. 6.2 some million all in.
Yeah.
We'll reuse for irrigation about 600,000 gallons for the entire super block a year. It really, those two projects, Highland Bridge and Allianz Field, are what led to the creation of the city's green infrastructure district, which is what allows, to Bob's point, allows the city to assess for these green infrastructure components that Russ and his colleague now has left the city, but Wes Saunders Pierce, some of you may know, Russ and him were really instrumental in driving those policy changes that I think maybe it was Becky or someone mentioned in their intro that those policy changes do have real world impacts. And so we're excited to have the tool of a green infrastructure district to implement at the Heights here.
Yeah.
Should I keep
on to the next slide then, Becky? So we'll talk a little, just a couple minutes about the practices. And every engineer comes at this, they have a preference for certain practices. We try to be open-minded on it. Obviously, there are large-scale underground storage on industrial sites. That's a very practical way of going about it. At the small scale, we have tree boxes and rain gardens. That's a little bit more of the aesthetic, though there are treatment aspects to it. Permeable pavements are one that get to be a little tricky. And this is sometimes where the meeting of the minds, I think we kind of align with Public Works on this a little bit, that we haven't had a great record of using them in the public, in the highly trafficked right of way, and anywhere where we have a lot of turning movements. They tend to grade and perform poorly, but there's a place for them in other areas where we might not have a lot of turning movements, not a lot of traffic, and certainly in plazas and public spaces where it's all pedestrian and bike traffic. So there's a place for them, and I think what you'll see in our designs as they come forward is that we're not putting them in we have an industrial development where we're going to have a lot of trucks running. We're probably not going to be seeing a lot of permeable pavement on the roadways, but we would be seeing it and looking for it in many, many other areas. Ponds are always a big part. Ponds they provide aesthetic benefits, habitat benefits, and really are a very efficient way to accomplish our flood control, which is also important here. Obviously, we have a neighborhood that we're living in, existing neighborhood. We've had a golf course, and now we don't. Now we have 72 acres of pavement or something like that. That's an issue that needs to be addressed, and ponds and the underground storage are the way we control the flood control. And when you talk about resiliency, we're using Atlas 14, which is NOAA's update to the flood control standards. To some extent, that's already resilient, right? It reflects rainfall that's been occurring the last 20 years. But we have redundant systems, and we've talked about this even among ourselves, that we have a flood control system that'll store up to 7 inches of water, or a 7-inch rainfall. I don't know, Bill, what is it, 7.4 in St. Paul, something like that. So that's a fairly substantial rainfall. But then we have a water quality system that's also in there that has additional storage. We have a conveyance system that has storage. We have parking lots. So there's a lot of built-in resilience into the system, when we have to be very careful about how we allow that built-in resilience to be tapped into. And I'll just give you one example. I had a client once that they had a parking lot, and they wanted a certain level of drainage and service in their parking lot. But if they had decided that they could live with the kind of the minimal level of service and drainage on the parking lot, they could have reduced their flood flows by like 25%, right? There would be transitory storage within the parking lot. That to me is what resilience is. It's trying to look at all the different systems that we're putting together and how one can augment the other. Flood control can be augmented by water quality. Flood control can be augmented by conveyance. Flood control can be augmented by other surfaces that may be, adequate for temporary flooding. Chambers, vaults, cisterns for reuse are all kind of in play as well. Those become kind of a minor part of the flood control system, but a major part of the water quality system. And then they take stress off the potable water system, which is a separate benefit that the project can provide. And I mentioned wetlands for finishing. I always, people forget about wetlands as a part of a water quality system. Obviously, we have to treat to a certain level before the wetland, but the wetland does certain things too that we have to acknowledge, and that's part of the resilience of the entire system. So permeable surfaces, I think, and I think of this more broadly. So we have pavements that we can make permeable, right? But the easiest way and the best way to me to tap into permeable surfaces is to disconnect those surfaces that aren't permeable. Right? So we have parking lots, we have roofs, we have a lot of different surfaces that we're going to be building, many of which will not be permeable. They'll be regular hard surface concrete or pavement. To the extent we can detach them, meaning they don't go necessarily to a catch basin and immediately into a storm pipe. Detaching means that we're taking small little drainage areas and we're running them off into a boulevard. It could be turf. We've used hybrid fescue little areas for this. It could be rain gardens. There's a lot of different ways of doing it, but one of the things that we think about when we think about permeable surfaces isn't just permeable pavement, though. It's using the 30% permeable surface that we're going to have out there anyway, right? We're 72% or whatever paved, we're 30% or 28% unpaved. So how do we use that 28% unpaved surfaces and disconnect the permeable or impermeable surfaces and run them over to them? And why do we do that? I mean, permeable pavements themselves are really more filtration systems. They don't provide a lot of biologic activity. They don't allow for evapotranspiration and other sorts of effects that, while we don't quantify those necessarily, we know they exist, right? And we know that we want to promote them. So the idea of the disconnected impervious is now we're tapping into these other elements that really just improve the level and quality of the treatment that we're getting out of the overall development. You can go to the next slide, Becky, which I think is, contamination remediation. Still me. Monty, I didn't know I had this much material. Becky, you really stretched it out. Thank you. So contamination remediation, I talked about needing to be careful with infiltration when we have contamination. And there's the practical of being careful, right? You have contamination. You don't want to drive contamination into a groundwater table. And so when we do infiltration, we're mounding up water, we're increasing the hydraulic gradient across the vertical plane, right? And we can drive water into sand beds or just veins and then drive pollution deeper into the soils. So we have to be careful about that. When we can't infiltrate because of contamination, we actually have an augmented water quality standard that we have to achieve by Ramsey Metro Washington Watershed District standards. So when you can't achieve infiltration, you have to just provide more retention, more volume for treatment. So that in areas where we can't infiltrate, we'll have to do that. But that said, we are stripping all the contaminated soil. So we are able, most of the sites I work with, we can't get at all the contaminated soil, right? It's deeper down or it's in the groundwater. We're dealing with a plume. So we're stuck, we can't infiltrate. But here we have access to all the contaminated soil. Right, it's all at near surface. It's all in the the fairways and the greens and the tee boxes, and it's within the first 24 inches of the soil. So we do have access to it. So working with the PCA, primarily Department of Ag, city and watershed, we're thinking we, in areas where it's appropriate, we can get infiltration into the development. Now, when we're handling these soils, the highest level of contamination soil will be removed off site. We have category 2 and 3 soils, or 1 and 2, that are less contaminated. And those are going to be specifically placed within the site so that they don't occur in areas where we have human contact. Typically buried 4 feet to meet the residential standard of separation. But also we're going to be careful about not putting them in areas where we have standing water. Again, we don't want standing water that might infiltrate to become in contact with contaminants and then get into potentially into the groundwater. So we're going to be cognizant of where we're actually putting these materials and getting them really out of the way and not near the surface so that people don't get or don't encounter them in the future.
Bob, this resilience and adaptation, slide, I think jives nicely with Chelsea's comment in the comments here, wanting to hear about strategies for drought resilience. So if you or Bill, while you're going through this slide, can be thinking about that in the back of your brain, I think that would be great. Hey, Jess, thanks for joining us.
Thanks for having me.
So resilience and adaptation, in terms of flood prevention, our standard is known as Atlas 14. Now, your guess is as good as mine as whether it's getting rainier over the period of record that Atlas 14 is based on, but it is a 7.4-inch flood event, and has proven to be robust. Bill and I have had probably, Bill, 5 years of experience now applying the standard. So we've seen some of the infrastructure built that we've used to design to this standard, and so far so good, right? We used to design to the 6-inch event. Some areas of the metro was 5.7 inches. So it is quite a bit more robust. So that resiliency is there.
The other thing I was just going to say, Bob, we could add in, flood protection in where we put flood storage areas or define flood storage areas is a component of resilience. But another component of resilience is just in best practice of site design, right? We're looking for events to convey that design flood event, but we're also looking for emergency overflows. We're looking for resilient aspects of the design. How do we route stormwater that's in excess of the 100-year event? And is there adequate capacity to convey that into areas that it's not going to impact structures, or, is there a reasonable depth of, that those large flows would build up to in critical access routes and things like that. All those things go into good site design. So even though you have a design flood event, and this carried true even to some extent into the previous flood event, and that's we moved into Atlas 14, by good site design of providing these emergency overflow routing, we found in some cases that even though the design storm event increased by 25%, we started utilizing those emergency overflows, but we still weren't impacting necessarily structures in many cases because we'd been mindful about, this is a design storm event. It doesn't mean that we're not going to get more rain than that. Those things happen. We do have those large storm events that exceed even the 1% chance event. So that's how we look at building resilience into a design, so that down the road, if Atlas 14 gets exceeded, we have some thought put into that.
Thanks, Bill. Additionally, I talked about this. We have in certain areas where we can't infiltrate, we'll have an augmented water quality volume standard, which adds a little bit of additional resiliency to our storage and flood control protection. This is one that doesn't often get considered, but one of the things that we feel is important is having a lot of shallow vegetated overland conveyance in these occasional areas that take water. By just disconnecting impervious or routing it to some extent through overland conveyance that's vegetated, we slow it down quite a bit. I mean, the velocity we see in a pipe can be 5 or 6 feet per second. The velocity we get in a well-designed overland channel can be 1 or 2, and that really significantly changes how water moves through a site. And it's called attenuation, but when you attenuate, basically you flatten out the flood hydrograph and you spread it out over time. And that's important. It's really surges that hurt people and structures. It's not overall volume so much as it is how much, like Houston, 54 inches in whatever it was, 6 hours. That's the problem. 54 inches over 3 days maybe is quite a bit different. Well, that'd still be a problem, but you get my point. Yeah. So the idea of slowing water down and how we do that, and one of the best ways is not only the overland conveyance, tree canopy is another one. Now, this site is difficult in trying to create the pads we need for industrial, but we'll be planting trees, and to the extent that we establish and rely on tree canopy, the interception of tree canopy can be, a tenth, 2/10 of an inch in some rainfall. So it's significant. And as you can plant a tree canopy that can cover your site, you do two things. You intercept rainfall, but you're also, toward drought resiliency, you are creating a situation for turf and other plants where they are a little bit more resilient. You don't have the baking sun on them, and you don't lose soil moisture as quickly as you would when you don't have a tree canopy. And I think when I think of drought resiliency too, I think of vegetation choice as being important. Irrigated turf grass, a little difficult, right? And I don't find that to be a resilient practice. To the extent we can have more robust vegetation, I think we provide a little more drought resiliency. And then to the extent we can recycle water, we do that as well. And another aspect of this, and what will be important, is good housekeeping. Good housekeeping covers a number of different practices, but it's really how owners treat their sites, right? And we know when we drive by sites that are well kept, we know what we're looking at, and you can tell when owners don't keep their sites in good order. It starts with picking up trash, but it includes sweeping, a periodic and regular sweeping. If they do have permeable pavements, there's special equipment that probably we would ask them to purchase or would be available to them for vacuuming the permeable pavements or sweeping those. We would have maintenance agreements with any private BMPs. Those maintenance agreements would extend to vegetation maintenance and items like that. And that will help with any, just in terms of overall water absorption and being, if good maintained vegetation will improve the resiliency of the entire development.
Bob, I was going to add in too on good housekeeping, some of the design elements that go into this. We can make the most resilient and all of the most innovative. We can apply all these great ideas, innovative BMP or, treatment devices and habitats into a design concept, but there's got to be a maintenance consideration that's put into how do we get to access to do maintenance. Like if we put something underground, are we putting the appropriate number of clean out structures or access points? Can somebody get in and maintain it to continue? Because spending all this money on infrastructure that only lasts 5 years and then becomes ineffective, it doesn't achieve anybody's goals. And so using that O&M lens and kind of asking those questions of the crews who are out there maintaining them, how can we design this differently or better, or use how they're actually going to be effective at keeping these things operating in mind is important.
Thanks, guys. I'm going to fly through a couple of case studies here. Let me just open them up.
And Monty, I'd say we are running a little bit behind, so if you want to speed through them.
I will be quick. 2 different projects, our Beacon Bluff project and giant utility scale system, and then an industrial scale system at our Midway project. I haven't done this slide for a little bit, but this was a presentation I did for the National Association of Environmental Professionals in Honolulu in 2015. Beacon Bluff was our last 10-year large-scale redevelopment project, 1,000 jobs on 61 acres. This is the site we're going to drill into right here. There were some old 3M buildings, and a contaminated foundry was buried under these old 3M buildings we had to clean up. We had to build this road to create 2 nice development pads. And to build the road, we had to build some treatment to deal with the stormwater coming off the road. Well, what we realized was, after we got into this, right about where that treatment wanted to be was the creek bed of the old Phelan Creek that was eventually buried and put into a brick tunnel that drains right into Sweet Hollow Park and then right into the river. What we realized was this is all down gradient. The Beacon Bluff site is down gradient from this 143 acre sub-watershed district. So this is 143 acres of untreated, largely residential, small scale commercial, basically untreated urban runoff that was going into bigger and bigger pipes. By the time you got down here, there's a 4-foot pipe that went into the 8-foot brick tunnel from 100 years ago and dumped right into the river. Well, that creek bed was some beautiful sand we could infiltrate into. So we built this thing, utility scale underground infiltration system, got the city comfortable with it. They were not super excited about it, the storm sewer folks at the beginning, but we got them there. It is perforated 10-foot diameter pipes, wrapped. Different types of soil media were used, sand and aggregate, to both hold up the pipes and to provide filtration. Tire chips, what's called TDA, tire derived aggregate, is there's a PCA standing beneficial reuse for a waste product for tire derived aggregate. And if manufactured to a certain spec rather than putting in a landfill, it has a lot of void space, so you get a lot of storage capacity in order to, as Bob was saying, to slow down in a surge event that 143 acres of runoff. And then it's all infiltrating down into the beautiful sand below the system. But when we were trying to get this thing permitted, we were having some issues related to policy and science about how we understand how stormwater works. There's really a dearth of data internationally about how these underground systems perform over time and what the environmental efficacy of them is. And so we went down a rabbit hole that we're still going down on researching, providing research opportunities to create better policy around stormwater. We inserted infiltration rate monitors, these collection tanks for water quality sampling, these things right here. I mean, where'd they go? We literally, oh, they're coming up. We literally invented these sitting in the construction trailer, trying to figure out how to get these pipes and get the water, collect the sample we need. This thing, the bottom one, is like 12 feet below a system that is 20 feet below ground. So you were never going to be able to build this after the thing was built. You had to build these deep sampling pipes ahead of time. This was the first site to use a SAFL baffle. It was invented at the University of Minnesota at the St. Anthony Falls Laboratory, hence SAFL baffle. It's a stormwater device you put in a manhole. I liken it to shooting a garden hose at a cheese grater. It really disperses the energy, and Bob and others will laugh because that is not actually how this thing works, but kind of. It interrupts the scour, the swirl in one of these manholes, which picks up the sediment and pushes the sediment downstream. That's what these SAFL baffles do. This, like I said, was the first installation, and I believe this is now standard practice at Cap Region Watershed District to require SAFL baffles in manholes to some extent. This is a whole thing about metrics feedback loops and the idea that we have BMPs that say we're supposed to do good stuff with stormwater by infiltrating it. We do modeling and we get some site soils data, but then we don't do a lot of actual metrics. Cap Region Watershed District has several monitoring sites. 2 of them are ours. Ramsey, Washington, where this watershed district, where this site is located, I'm not sure. We haven't gone down this rabbit hole with them. But it seems to me that most watersheds are interested in sites where they can monitor and analyze and get real world metrics feedbacks from these types of systems. This is our infiltration rate monitoring. You can see that in one day rain event, we inflowed 1 million gallons in that system on May 24th. And this was 2012, it looks like. You can see here the system outlet, total outflow volume, 0 cubic feet, meaning everything that came into that system was being infiltrated and recharging the aquifer. So when we talk about stormwater, we talk about ecosystem services. And what are the valuable ecosystem services that stormwater help us hold up? Aquifer recharge is a big one, right? Water quality. This next slide will talk about the speed by which we are transferring surface water contaminants to groundwater. And these are things that I didn't understand when I started working on this stuff, but some of the folks at St. Anthony Falls Lab and some of the other scientists have taught me a lot about, and we got into a partnership to study these systems. Now we're working with the Pollution Control Agency and the Watershed District, where the PCA is providing lab time and lab analysis. The watershed is providing the labor to go collect the samples. The Port Authority is paying for the instrumentation of these systems. So the University of Minnesota Met Council spent, this is Dr. Gulliver's work, Met Council spent about 400 grand with U of M studying this system. I tried to present this and to the National Association of Environmental Professionals, not being a scientist, but we wonder, right, about the performance-based justification for these BMPs, for this infrastructure. You know, there is policy and there's practice, and at a policy level, infiltration's good. How much infiltration is good? How much sand do we infiltrate through to accomplish what environmental water quality goal? These are tough answers because there's not a lot of good data. So, but you can see from this laundry list, some of the assumptions about what infiltration accomplishes might not be completely accurate from an environmental efficacy perspective. Metals and petroleum hydrocarbons more likely to enter groundwater. That's the concern of some of this cohort of scientists. We don't seem to be attenuating petroleum. We don't seem to be attenuating nitrate concentrations. You know, the idea of introducing high organic content around these infiltration chambers, well, that kind of runs counter to what, you know, most civil engineers would tell you is, oh my God, well, you start putting organics in this thing, it's going to clog up. It's going to plug up over time. So these things do require oftentimes a high degree of maintenance in order to function properly, especially these underground systems, which is why some of our older school engineering friends don't like them and frankly hate them, because they do cost money to maintain, but we can, if done right, achieve higher levels of environmental performance. This was just a whole mess of a calculation by which we saved the city about $500,000 by selling them infiltration credits for 50 cents on the dollar. And we won a bunch of awards for it. So I just wanted to introduce you guys to this idea of these research stations. And we haven't talked about doing that out here. You know, we don't have potentially a huge infiltration gallery system like this. But I think this is the type of work that helps us move the industry forward and helps us move our understanding of these BMPs forward. Selfishly, from my perspective, the initial toe in the water was, hey, that Phelan Creek bed out at Beacon Bluff, the dual ring infiltrometer test says that sand is going to drain at 20 inches an hour, but the watershed only will give us a permit as if it drained at 2 inches an hour. So are we building that huge system? You saw that tiny little person standing on that huge system. Are we building that system 10 times larger than it needs to be? I mean, talk about resilience and redundancy. That seems a little ridiculous. But you would ask the watershed, we did ask the watershed back in 2014 or 2010, whenever it was, well, how come only 2 inches an hour? Well, because there's not enough data. We don't know how this thing's going to function in 10 or 20 years. So we're going to be conservative and give you a permit for 2 inches an hour, not 20 inches an hour. So just want to put that on the table. If folks are interested, there's a whole another world of science that this site could participate in. And I think it's at least worth approaching the watershed district, Ramsey, Washington, who I'm less familiar with, about some of these ideas and seeing how game they are. But I know from experience, Cap Region was all over doing this kind of stuff. And now I'll switch back and we're going to stop. Actually, let's go to talking about what you guys think about stormwater. And it doesn't have to be technical, but you know, down here, oops, did I lose that share? I think I did. 1 second, coming back. You see that now? So this is what we wanted to get to today is, you know, at a high level, what do you guys think we should be accomplishing with stormwater at the Heights? You know, these are some of the ecosystem services that we know can be impacted and we can influence positive outcomes on. Are there things that are resonating with you guys after seeing this stuff? What do you think? Chelsea?
Hi. Thank you for the presentation. I've learned a lot, and I guess like just anecdotally as somebody who lives in this neighborhood, last year I was really excited to see a lot of new trees planted because obviously we, you know, with emerald ash borer, a lot have been cut down. We lost a lot of trees. And so I saw a lot of trees planted and I was very excited about that. And then we got the drought. And I don't know, you know, how many trees, how that affected, especially the young trees. I know that's very stressful. And so I'm curious, that's why I asked the question about drought resilience as well. And the way you were talking about slowing down the water in storm events makes so much sense. And if there's also a way to hold that water so that it can also be used in drought events, that is the other side of resilience. And for like these large underground storage facilities, if there's a way to draw on that water when it's needed for irrigation, because obviously we'll be planting a lot of new vegetation and trees on the site, and it would be nice to use that stormwater resource for those new plantings.
Yes, yes, and yes. We have not contemplated a stormwater reuse system out here. Being that there isn't a central collection point, this is a more distributed system. And those things are very expensive, frankly. Mm-hmm. I think one of the early conversations or suggestions by one of the consultants was, you know, black water and gray water reuse, meaning sanitary and dishwater reuse, toilet water and dishwater reuse, which is a whole nother level of expensive from just collecting stuff off the rooftops and storing it for later irrigation use. You know, if money were no object, we absolutely believe stormwater should be used as a resource, and there are multiple cascading benefits to doing that. But you got to figure out how to pay for it on the front end. And I think there's maybe a little hangover of the cost implications of doing it at scale over at Snelling Midway. Russ, I don't know. What do you think?
Yeah, I mean, I think you're right in terms of the experience so far over there. A lot of that has to do with the fact that the rest of the development hasn't transpired, and so you don't, you know, all the upfront cost was borne, and you don't have people now plugging into the system and paying on an annual basis. And so I think that's some of the nervousness of our folks in the storm sewer utility, just because even though we've built out these new systems, they really haven't been put to the test yet in the way that they need to be. And, you know, Highland Bridge is just coming online. In fact, I was just hearing that the public spaces might be opening up down there pretty soon for people to be able to start perusing. But yeah, and so to this point of like high maintenance, you build stuff that is high maintenance, you also have to build in the funding stream to pay for that maintenance, right? And so that's what we've been trying to do with these stacked green infrastructure projects, but those revenues haven't really materialized yet because you know, we built out these kind of district-wide systems and the full districts aren't built out. So all that to say, I think there's still a lot to be learned with how these systems are going to function. A lot of work went into like figuring out the kind of the numbers behind what you charge folks to plug into this system, and it hasn't really been fully tested yet in those two other cases. But and so I appreciate the comment, Chelsea, about, you know, high maintenance actually being a source of jobs, and it is. But the worst case scenario is you build something high maintenance and you don't do the maintenance, to Monty's point, and it just and then you end up in trouble.
The system at Beacon is not performing as designed right now because it has suffered from some lack of maintenance. You know, I think it's a worthwhile challenge to our design team, Chelsea. What is a low cost way, you know, in the very near term, just as we plant these trees, what is our our drought resilience plan to make sure we don't lose half of the new trees we plant in any given summer before they're well established, which may be related to, but also might be a different challenge than what is a low cost, low mechanical, a non-UV filtered way to access that stormwater resource for times of drought. And I don't know, but I think that's a challenge we can bring to our design team and see if we can figure out something cool. That's what I love doing with these folks, is saying, I know it's easy for you to figure out this bookend, which is what's the cheapest thing I can do to get a permit. What's the other bookend? How far can we push this before we break it? And that's part of the issue with the cost, particularly the one at Allianz Field at Snelling Midway, is that water was required to be treated to a drinking water standard just in order to use rooftop water for irrigation. It's plumbing code and all sorts of stuff come into play. That's the reason the reuse at CHS Field of rainwater to flush toilets literally has signs, if you've been there, at least the men's urinals have signs next to them saying, do not drink this water. Well, it's a goddamn urinal. I wasn't going to drink it. So maybe there is some other, you know, if we keep it underground and it never surfaces and so no one can get Legionnaire's disease or whatever, what is the engineering solution to deal with the issue you've addressed, Chelsea? So we will lay that at the feet of LHB and WSB and see if they come up with anything cool. Other thoughts or comments on stormwater? Otherwise, we'll keep moving. Going once, going twice. All right, Becky, let's talk embodied carbon.
Yeah, and in terms of a time check, I think we better go through embodied carbon pretty quickly. Monty, how do you feel about postponing the workforce section until next time? And then we will try to save at least 5 or 10 minutes to talk about next steps, because that has to do with a couple of things we'll be asking you to look at between now and next time. And Bill and Bob, you are welcome to stay on if you would like to, or you're welcome to hop off. Embodied carbon is a very, I guess not exciting to everyone, but a very exciting topic. All right, so.
It is interesting, but I will sign off. Thank you.
Thank you for your time.
Thanks, guys.
Bye.
So embodied carbon was one of the other topics that we heard work group members were interested in hearing more about. Just so that we're all on the same page, embodied carbon is the emissions that are associated with materials and construction processes over the whole life cycle of a building. So it includes mining or harvesting the raw material, manufacturing that product, transporting it, using it, and disposing of it. And different materials have differing levels of emissions at each one of these life stages. And decisions made can impact the overall emissions. So in this example here, using a basic oxygen furnace versus an electric arc furnace to manufacture steel can result in a 50% drop in the embodied carbon. Similarly, transit distances, end-of-life disposal methods, and that type of thing. On the next slide, we'll talk about why it matters. So the pie chart is showing that about 20% of global emissions come from building materials. And the chart below shows that about half of total new construction emissions between now and 2050 will actually be from embodied carbon. And in the near term, about 2/3 of the carbon emitted from new construction of highly energy efficient buildings between now and 2030 will be from embodied carbon. So it definitely is an impactful area and matters especially in the short term as we're kind of approaching this tipping point for kind of catastrophic climate impacts. I'll kind of skip over. Global organizations have set a variety of reduction targets that you can also see on this slide if you want to revisit those. So based on this information, our project has, I will also just say that embodied carbon has really come a long way in terms of what we know about it over the past 10 years. And so there are now many more strategies and tools for quantifying embodied carbon and reducing embodied carbon, but it's definitely an area that's still ripe for innovation and kind of ongoing development. And so that's kind of informed the goals for this project. The first one of which is to quantify the community's embodied carbon impact. So we are recognizing that when we're talking about carbon-free community, that definition is looking at once the development is fully built out, which is missing this major source of emissions. So we want to be able to quantify this so that it can become part of that narrative. We also are looking to raise awareness of this topic on every project to help move the industry forward in addressing embodied carbon, along with capturing any low-hanging fruit that is accessible across the development for easy, low-cost strategies to reduce embodied carbon. In addition to that, we're hoping to make meaningful reductions in high-impact areas, so looking at the building types and systems that have the biggest impact on embodied carbon emissions. And then ideally, we'd like to include at least one demonstration project that can really inspire and inform future change. And this is where hopefully at some point, John Metza will be able to share some of his ideas about this.
Becky, I will add, I had a conversation earlier this week with a gentleman from Semstone, and they have some ideas and I think are interested in a pilot project here. And we had a long talk about Portland cement and a 50% reduction in embodied carbon based on the cement mix and the inclusion of fly ash or not, et cetera, et cetera. But these industries are starting to get smarter because people are starting to spec these type of LCAs, these type of life cycle analysis into their building projects. And we will, at this point, we do have sustainability covenants, and maybe we're going to get there, Becky, that talk about requiring an embodied carbon analysis for these buildings.
Mm-hmm. Yeah. So I'll quickly address some of the areas of biggest impact. In general, materials like concrete, steel, aluminum, plastics, foam, refrigerants, and even some interior materials like carpet and gypsum board. There's opportunity in each of those. In terms of building systems, the structure and exterior enclosure, so the two darkest gray bars in that bar graph at the bottom of each bar, have a larger initial impact than interior finishes and building systems. I will note that as those interior finishes and systems components get replaced over time, they do have additional embodied carbon 5, 10, 15, 20 years into the life of the building. So they do add up over time. It's just not as big of an initial impact. And then just in terms of building types, heavier buildings typically have higher embodied carbon intensity than lighter buildings. So there are strategies to address this, and a recent report from the Rocky Mountain Institute found savings possible of 24 to 46% at cost premiums of less than 1%. So a couple big picture strategies: build less, reuse more. The biggest opportunity for the Heights, which is new development for that, is designing for disassembly. Another strategy is to build lighter and smarter. So this bottom image is a prefabricated modular housing approach, which can really reduce construction waste. The top image shows using life cycle analysis to optimize the building envelope in this case. So the design team was able to greatly reduce the embodied carbon while maintaining other design criteria like appearance and insulation value. Another strategy on the next slide is to use low carbon materials, whether that's salvaged or refurbished, materials that are bio-based that actually store carbon in them, like wood and linoleum. The graph of insulation is showing the difference between using an extruded polystyrene at the top for building insulation versus some of those bio-based materials at the bottom that actually are storing carbon. So switching even just from extruded polystyrene to a mineral wool insulation can make a big difference. And then once you've kind of settled on what materials are going into the project, you can procure lower carbon products. So Monty was talking about the ability to dramatically reduce the global warming potential of concrete by through the concrete mix, and that can be specified in the project specifications. Environmental product declarations can be used to identify lower carbon facilities. So remembering the difference between that, the two types of furnaces to process steel, and those EPDs and global warming potential limits can be incorporated into project specifications at a relatively low or no cost to the project. So looking at how this is integrated into the Heights currently, the master plan calls for the project to model embodied carbon for all construction and use materials and techniques that lower it to the greatest extent feasible. The way this is incorporated into the covenants, the draft covenants, is that buildings other than single family homes will need to conduct a life cycle assessment of the structure and enclosure, which remember were the biggest components of embodied carbon, and then evaluate the feasibility of reducing global warming potential by 5 to 10%. And this is based on language and methodologies from LEED's Building Life Cycle Impact Reduction Credit. The idea would be that with this assessment, plus during design team meetings with the port, some education and providing resources about those low-hanging fruit and high-impact strategies, that we'd be able, developers would be on board to make a difference in this area. So the next slide shows kind of that approach of requiring assessment and evaluating reduction potential, encouraging high-impact and low-cost strategies through education, and just a reminder that we're currently focused, the covenants are focused on the structure and enclosure rather than mechanical, electrical, or interiors, although those topics could certainly also be raised in the design team meetings. So if we could just take a couple minutes at this point to hear any immediate feedback on your thoughts to our approach on embodied carbon at the building scale. I know it was a lot very fast, so you can also take some time and get back to us via email. But any initial thoughts?
Russ, I can't remember, does the city sustainable building policy get into embodied carbon or not?
I don't believe it does, Monty, yet.
I
I
couldn't.
think this came up briefly in some conversation recently, but I think we're maybe due for another update soon.
Well, we are trying to understand the impact in the marketplace of requiring a life cycle analysis for embodied carbon. That's a new one for us. And so LHB has been pushing me, and I've been pushing back and trying to make sure we can keep people on the bus here in terms of building buildings and bringing their jobs to the Heights. But we have had success for years in putting good information with cost savings and environmental benefits in front of buyers and them making a business decision. It's tough when the business case isn't there, and we have the data now in many cases to show that there is a minimal cost or a cost savings for many of these strategies. So we're willing to give it a shot because we know it's the right thing to do. Should we keep rolling, Becky?
Yeah, I think we can.
Oh, this is going to be John's slide. I can just tell you because there was a note on one of the other slides about sustainable sourcing sustainable wood. And John Metza, who's on this work group, and is a business owner in the area, he wants to build a building at the site. You've probably heard him say. We helped sponsor a grant application. The Sustainable Forestry Initiative wrote a grant to USDA to hopefully, and part of it was to the port's obligation or responsibility in that grant application is we said we would encourage mass timber with our covenants, specifying it as an eligible and preferred material for construction, et cetera. And John Metza was in that grant application because hopefully, I can't remember if it was a couple $100,000 or something, would actually help pay for the cost differential for him to build a mass timber net zero building on site. So we haven't heard back about it, I'm sure yet. I'm sure I would have heard about it if we did get the grant, or if we didn't for that matter. And Sustainable Forestry Initiative, you may know, is kind of the industry's attempt to keep up with the Forest Stewardship Council, who are the more activist advocate types. But I do know the person at Sustainable Forestry Initiative, Annie Perkins. I've been on the U.S. Green Building Council board with her for years. She was at Anderson Windows before that and has done great work in the sustainability field. So at least I know she's not a shill for the industry, but they are trying to make progress in this low carbon mass timber construction. I was at a meeting over at T3 in Minneapolis the other day, and it just is such a warm, beautifully aesthetic material. And it does such great things with carbon. It'd be great to see more of it. Workforce, we're going to skip for this meeting. And next steps. This is what we wanted to talk about before we wrapped up here today, right?
Yeah.
Why don't I start, Becky, and you remind me if I forget something. So we were having a discussion about what the work product of this group would be. And we're hoping that we can get to a point by the end of these sessions to have a set of consensus recommendations. Maybe it's a short 2-page memo that, looking around the work group, everyone can nod their head and agree with and live with, that documents this group's top sustainability priorities, the things that you really like and want to endorse or support that we're doing, and also areas that you think we need to go further on, or areas that you have concern that you don't think are being addressed that you would like us to address. And we will obviously take those things seriously and do our darndest to make them happen. The timeline for this, we don't have a meeting on the 29th. I think maybe, is this via email they're supposed to do this?
Yeah, we were thinking this would be a 2-part homework where by next Friday, each work group member, and we'll definitely have to communicate this quickly to the folks who aren't here, would propose topics to include. So whether that's just love the next generation stormwater district approach, could be as simple as that, or it could be more detailed bullet points or paragraphs or sentences that you'd like to get into the draft. We have a pretty quick turnaround for our team to create the draft document based on those proposed topics and potentially other things that we've been hearing at these work group meetings. Turn that back to the work group members for you to review the draft, and a couple days before our next meeting, provide an email with any comments or concerns that we can kind of frame our next conversation about on May 20th, which is our final meeting. And then we'd be able to, during that final meeting, walk through any areas that you feel like need to be further discussed before deciding what gets included in those consensus recommendations, or areas where there might be conflict or tension with between different recommendations. So it's kind of a tight timeline. We might not be able to finalize the document during that May 20th meeting, so there might be another follow-up to have a final draft and kind of approval.
Becky, I know Tiffany and Jess know I'm out of town this coming Sunday, the 24th through May 4th. Vacation, coming back for a couple days, presenting at a conference for DEED, and then leaving town again. So that might be a little tight if you need my little brain power, which you probably don't, obviously. But Chelsea, you had your hand up?
Yeah, I'm wondering who is the audience for this document? Like, who will be reading this?
Good question. The master plan, I just saw a note, is going to City Council public hearing on Wednesday, May 25th. That these were intended to coincide, but that public hearing and getting the master plan approved will allow us to begin all this good work. They're helpful for our internal team. I've tried to tell our technical team, if they dream up something, and because I as project manager say that's a great idea, but it either costs a lot of money, or it takes a lot of time, or it's a big pain in the ass, it's not necessarily the best basis for me to even build internal support to get the traction to go do whatever that thing is. But if I have a document from this group saying, hey, these are important things, that gives myself internally and with our external partners the agency to run around town saying, we're supposed to be doing this stuff. We did engagement, we had a work group, we all talked about this stuff. These were the things that floated to the top. These are the consensus recommendations. And it's not just Monty and the hired guns that think these are good ideas. There are other smart, plugged in people who want to see the Port Authority as a public agency go do this good work. So as you can imagine, there would be innumerable public and private sector audiences that we literally have to sell on doing this work on a daily basis for the next decade, frankly.
Okay, yeah.
It gives the grassroots support and initiative to push an industry, several industries, probably out of their comfort zone, and to give me the political cover when those industries come screaming about what in the hell are you saying I have to do. Again, it's not just me. That's part of the coalition building, if you will, around this fairly aggressive sustainability strategy for the Heights. Russ, do you think that's a reasonable explanation of how this group is documented and sort of leveraged moving forward?
Yeah, I think that's a good summary, Monty. And I think today's presentations are really relevant to sort of the things on the site that are some of the things on the site that are possible to get to in terms of best practices that aren't like that extreme reach, but still best practices on the stormwater front, potentially the pilot with the embedded carbon, with the Metza development if he's up for doing that. And from my perspective, really continuing to stick to the big, bold part of the vision of net zero, being the thing that if we were all able to accomplish together would be quite the thing.
Yeah.
That we could potentially do. And so and that's going to be a I think we've all kind of agreed that's a big challenge in and of itself. But to the degree that this group's work kind of endorses that vision and says, this is what we're aiming for here, and here's why we think this is a great opportunity. It certainly helps. with all those audiences moving forward.
Absolutely, Russ. Thank you for that. We do need to continue to build this coalition of support to do the big thing and pull the big lever, which is building net zero at scale. And that's, I think I've told you before, it's $100 million of reallocation of capital that is not standard or conventional in the industry. We're asking folks to do some pretty radically different stuff. And even if it's not money directly out of their pockets, it still doesn't feel exactly like what they would have to do if they went somewhere else. So the more support we can build for that big dream, the better.
That's right.
Other questions about next steps other than we may get a little pressed for time second, third, fourth week of May here.
I do have one question about the 429 timeline step. This may just be obvious confusion on my part, but are we proposing topics to include for the final draft recommendations, or is it for topics for the next meeting?
For the draft recommendations, which is going to be the bulk of the content for the next meeting, but it's what do you want to see in there as your top priorities?
Yeah.
Okay, got it. Thanks.
And we'll get an email out to the group to that effect. Actually, Becky might have to get an email out to the group to that effect. Otherwise, I'm not going to get a vacation.
I can do that.
Thank you, Becky. All right, guys. Well, happy Earth Day. Have a great weekend. Happy Friday. Thank you for your time and attention to some of our most pressing concerns. Thank you all.
Thank you.
Happy Earth Day.
Happy Earth Day, everybody.
Happy Earth Day all.